Today we'll be looking at the laws of indices. So we start as follows. Supposing we have a variable, let's say x raised to power 0. So this will always give us 1. So any number or any value raised to power 0 will give us 1. For instance, if we have number 2 raised to power 0, this is equals to 1. Let's look at another law. When you have any value, let's say x again, raised to power 1, this is always equals to x. So we see an example of the following. Supposing we have, let's say 4 raised to power 1, this is always equals to 4. We look at another case. Supposing we have x raised to power minus 1, this is could be written as 1 over x. So let's see an example. For instance, supposing I have 3 raised to power minus 1, this could be written as 1 over 3. Again, even if you have something, let's say 1, let's say we have something of this nature, we have 3 raised to power minus 2. This could as well be written as 1 over 3 raised to power 2. So when you take the inverse, the minus at this point goes and you have 2 there. Well, we can also have another example of this type. Let's say, supposing I have something like, let's say 4 raised to power minus half. Okay, this could be written as 1 over 4 raised to power half. So when we take 1 as the numerator now, whenever we take 1 making it the numerator, this minus will go. Okay, that's what we are doing. So we look at number 4, another law. Let's say number 4, for instance, we have x divided by y all raised to power minus a. So when we have something like this, we simply invert. So what do? We interchange y. So it goes like this. We interchange y and x. So I will now have y over x. Now this minus we have here, this minus will go. So this becomes raised to power a. Okay, this becomes raised to power a, like we have there. So we look at an example. Supposing we have something like this. Supposing I have 5 over 2, okay, raised to power minus 3. This could be written as 2 over 5 now, raised to power 3. So the minus goes, we have plus 3. So example 5, let's look at law 5, for instance. If I have x raised to power a, now all raised to power b, so we can leave out the bracket and say that this thing is the same thing as what? A times b. So we can look at an example. Supposing I have 5 raised to power 2, and now I have all raised to power 3. This I can write as 5 raised to power 2 times 3, and this will simply give us 5 raised to power 6. Okay, so we look at another law. That's number 6 now. Supposing I have, whenever I have x raised to power a multiplied by another x, let's say raised to power b, this will give us x. Okay, so we now add, we now have a plus b. So we don't make the mistake of calling this one. So this one will now become plus, no longer multiplication. Okay, so we can have an example. Supposing we have something of this nature. We have 3 raised to power 2 times 3 raised to power 5. This will give us 3 raised to power 2 plus 5. Okay, this will now give us 3 raised to power 7 when we add 2 and 5. So another law, we have another law like this. That's number 7. Supposing we have, so we look at division this time around. Supposing we have x raised to power a divided by x raised to power b. Okay, so how do we look at this? Remember that this is the same thing as saying that x raised to power a over x raised to power b. That's the same thing. So this will give us, by the law of indices, it's the same as saying x, okay, raised to power now a minus b. What do you observe? This division we have here is what we are looking at minus at this point. Okay, so we can just take a very simple example, something of this nature. Supposing I have, let's say, I have 5 raised to power 3, now divided by 5 raised to power 2. This is nothing else but 5 raised to power 3 minus 2, and this is 5 raised to power 1. By the second law, we know that this thing is equal to 5. Okay, good. So we can look at number 8. Supposing we have another law, let's say number 8, for instance. Okay, I have 8. Let's say, supposing I have x raised to power 1 over a, something of this nature. This is the same thing as this. So now this is the 8th root of this variable x. Okay, so we can look at an example. Supposing I have a number, let's call it 9. So I have 9 raised to power 1 over 2. What do you observe? Now, you observe that my 2 now at this point, this is my 2, okay, is now is my 8. So my a now, this my a is being replaced by 2. So this becomes square root, because when we have 2, it is square root. So I don't need to write the 2 at this point. It's no longer important. So I'll now have this as the square root of 9. Remember, when we're talking about square root, this is written as plus or minus. So this will give us plus or minus 3. Then we can look at the other law. Okay, we'll look at another law, for instance. So let's take away this. So the final law is the law number 9. So let's see how it goes. So number 9 is this. It will be written as, so I have x raised to power a over b. What do you observe? My a, this a now, is no longer 1. So I have a there. So how do I write this? This could be written as the 8th root. So I have 8th root here, x, now all raised to power b. All raised to power b. So we can look at an example. Supposing I have 27, okay, raised to power 5 over 3. This could be written as the cube root of 27. So this is cube root of 27. Remember, I have to put 3 here to indicate it's the cube root. But if it is square root, I can omit that too. Now, all raised to power 5. Okay. Remember, the cube root, you are looking at the number that will multiply itself 3 times to get 27. That is 3. So this will give us now 3 raised to power 5. Okay. So this is the same thing as 3 raised to power 5. So in the subsequent class, we'll be going into further examples. Thank you.